So question 5 on your homework asks you to draw the reduction mechanism of fumarate to succinate using FADH2. I want you to do the arrow pushing basically for this. So we're going to be starting off with fumarate right here and moving in the reverse reaction to make succinate using FADH2. All right, so how does this happen? Well, FADH, at this point, I don't want you to know for this reaction if it's doing this in a radical mechanism or a hydride mechanism, but FADH can actually do both. So I'm going to show you both the hydride mechanism first, and then later the radical mechanism. I personally think drawing it as a hydride transfer is a lot easier, but if you chose to draw it as a radical reaction, or if you did that on an exam, I'd be fine with that too. All right. So this part over here, all right, this is basically the business portion of FADH2. So we have these two nitrogens here that both have hydrogens on them, hence the H2 part of FADH2, the name. Now, one of these hydrogens is going to leave FADH2 as a hydride. So that becomes a very good nucleophile that is going to attack our carbon-carbon double bond. All right, now this pushes these electrons either over to this carbon, or in a single step they can go and accept an H plus from the other end of FADH2. All right, now that's going to free up these electrons to collapse back down here, and that's going to cause these ones to collapse back down here, and we're going to end up now with our final product where we have our what used to be our alkene is now reduced and protonated, and we've taken our FADH2 and turned it into FAD. Now we can also do this in a radical mechanism. Right? Here I'm showing you the entire radical mechanism happening in one step. It could possibly happen in multiple steps. But basically what we're doing is we're taking the two electrons that are in the alkene here and splitting them up. So one electron is going to form a bond with one of these two hydrogens on FADH2. The other electron is going to form a bond with the other hydrogen from the other end of FADH2. So we're drawing a whole bunch of single-headed arrows here. So single-headed arrows indicate one electron being transferred. So one electron is coming from the alkene. The other electron is coming from the hydrogen-nitrogen bond there. All right, and likewise down here, one electron from the hydrogen-nitrogen bond, one from the alkene. All right. Well, this leaves an unpaired electron here on on both of these nitrogens, actually. All right, we're not going to like keeping both of these unpaired electrons there, so they're going to collapse back down and join up with one electron from this alkene bond. All right, and then one of the electrons will come up here to join up with that one. The other one will move downward to join up with the electron from here. And again, we're going to end up with our succinate and our final FAD product in this case as well.